Go. All right. Okay, so then so thank you for joining. So this what I wanted to know about, what our listener want to know about is like you're describing this project as revolutionizing how we manage energy consumption through AI driven payment. So for our audience who might be just starting to grasp the intersection of AI and traditional sectors, can you paint a picture of what this revolution actually looks like on the ground? I
Yeah,
mean,
sure. I mean, so
yeah, go ahead.
my my company specifically, never mind. We're hyper focused on AI agent payments,
Hmm.
and specifically like enabling an AI to pay another AI.
Okay.
Um, a use case where this sort of horizontal application of AI agentic payments starts to, I think, bear fruit is in smart grid management.
Okay.
Um, and so the company that I operate it's based out of Europe. And
Hmm.
so we know a company called Combiner, which is focused on um, enabling smart grid management, but through the context of like hyper localized distribution and consumption.
Hmm.
So less so where in your part of the world
Hmm.
where natural gas is free flowing and cheap,
Yeah.
especially in Central Europe, in particular the DACH region, Germany,
Hmm.
Deutschland, Austria, and Switzerland.
Hmm.
Um, there over the last 5 to 10 years, there's been a real push towards the adoption of solar panels and wind turbines at a local like retail level, right? So
Right.
to the point where in this region and in like places like Germany and Austria in particular, solar panels are so cheap that people use them to build fences.
Oh.
And so
Hmm.
as a result of this, there's a bunch of retail energy production
Hmm.
to the point where now there's so much of that production that in order to disperse it as a retail producer, you actually have to pay the grid to get
Hmm.
rid of the excess energy that's
Hmm.
being produced. Um, and so, you know, I think there's a movement towards at least diversification of energy production and consumption. In certain parts of the world, like in Central Europe, there's a big move towards green energy production and
Hmm.
consumption. And so the question becomes like, all right, if you're gonna say incentivize the usage and distribution of um, retail energy production components like solar panels, you've got to be able to handle like the discharge of excess energy, right?
Hmm.
Historically, that's been quite difficult because anybody that's in the grid management industry knows that like they're not very smart, right?
Yeah.
Um, and so this company that we've been working with, they're called Combiner,
Hmm.
and as I mentioned, their particular focus is on creating these localized networks of production and consumption at a retail level, so
Hmm.
that Etienne, if you and I were neighbors,
Hmm.
I could like hypothecate my demand for consumption
Hmm.
to you, my neighbor that's producing this energy
Hmm.
via solar panels, instead of, getting my energy from 150 kilometers away at a coal burning,
Hmm.
facility or a natural gas burning facility, right? So that's Combiner is trying to do that. And so um they've been aggregating all of this retail production and consumption data, and we got to talking, and we're on the AI side and specifically on the payment side, enabling AI agents to pay. So the idea here was like, what if we could engage, smart IoT,
Hmm.
right? What if we could, strap an LLM based agent onto like an HVAC system, in this case, like an air conditioning unit, right?
Hmm.
And handle. a non-traditional use case, which isn't, when everybody thinks of like smart grid management and smart consumption, it's always like, oh, when can I optimally tap into the grid to
Hmm.
like consume the electricity so that
Hmm.
I can lower my bills,
Hmm.
right? But in this case, in the dock region, looking at this scenario where, let's say, again, you and I are
Hmm.
neighbors, and Etienne, you are producing and you're overproducing, that actually costs you money.
Yeah.
So, what if I had an AI that was smart enough to predict when you were actually going to start overproducing
Hmm.
so that I could consume that energy locally and you don't have to push it back into the grid. You just fire it over to me. I fire up my air conditioning unit and start to consume that excess. So it
Hmm.
doesn't cost you anything. And now we start to get these like localized smart grid
Hmm.
systems going and the economies that take place within that. So, it could be like a bit quid pro quo. I'll turn on my air conditioner now and consume your excess the overproduction that you're creating. And then in the future, maybe migrate some of that capacity when I actually need it, right?
Hmm.
And so basically this use case was we created an agent
Hmm.
that would go out and buy the data feed from Combiner through their API
Hmm.
and then would statistically model based on historical information when you were likely to overproduce, as well as other data feeds like what's the weather data and stuff
Hmm.
like that, right? And in order to enable that consumption through
Hmm.
the Combiner API, we use Nevermind. So the agent is smart enough to say, okay, I need a new data feed, I need new information from
Hmm.
Combiner. I'm going to go out. Combiner gatekeeps their API using the Nevermind technology, and this AI can actually pay for access to that API to get the data feed from Combiner. So I mean, that's sort of the nascent
Hmm.
novel application of this technology. Interestingly enough, so we launched this in September of
Hmm.
last year, and in October, Mark Andreessen and Ben Horowitz on their podcast
Hmm.
talked about this almost identical use case and how it would be interesting, you know, um, to leverage AI in the to the benefit of creating smart grids, but smart grids at a localized level. So the reason why a lot of like grids are large and centrally managed is
Hmm.
because there's been a lack of ability to sort of
Hmm.
analyze the systems in real time without a massive centralization effort.
Hmm.
And
Hmm.
now we're moving to a state of the art where you can actually do that
Hmm.
energy grid management at the edges if you have the right intelligence at the edge.
Hmm.
So all of this talk about, smart IoT and being able to like, manage energy and consumption and usage and production in an intelligent fashion that's been discussed for 10 or 15 years is actually now coming to
Yeah.
fruition.
So
Yeah.
for consumer, like consumer like me, all I care is, I want to pay as little as possible, right? So that's all they care about, right? And they don't want to hear anything about AI, even if, you have AI in there. So is it going to be transparent for the user, or it's just going to help them, or is it?
No, it'll just be like your television now that
Yeah.
has like AI built into it to optimize the viewing experience.
Okay.
You don't know that there's like a neural network in your television
Yeah,
doing
that's
that
the point, right?
optimization,
Yeah.
right?
Yeah, exactly.
So in that sense, it's sort of passive. It comes with like the air conditioning unit, or alternatively,
Hmm.
it likely comes with the community that you move to,
Hmm.
right? Where that community is opted into this like combiner like system, where there is this smart grid capacity at a local level, right?
Hmm. Yeah.
It's interesting. Like in Canada, there's it's not so much necessarily discussion around maybe green energy production through solar panels and wind turbines, but more like, there's a lot of talk about like localized can-do reactors,
Hmm.
right?
Yeah.
And like positioning those in like local jurisdictions and having those
Hmm.
small reactors actually produce the electricity for small communities, right?
Yeah.
The way that the current grid works, that is, uh, y could you put can-do reactors locally in small communities?
Hmm.
Sure, you could. But managing, like, you're not going to build a new grid, right? So now you've brought in excess generation capacity, but you've still got the same grid that needs to manage the production of that in combination with whatever, like, the larger centralized massive distribution is, whether that's hydro or nuclear or natural gas or coal or whatever.
Hmm.
And so with these smart systems enabling, sort of natural language processing,
Hmm.
the ability to like, combine multiple neural network systems and transformer models, etc. We're just
Hmm.
moving into a state where um, the ability to apply that technology to enhanced grid management is improving all the time.
Hmm. And this is not only going to be applied to renewable energy. Is it like for other kind of energy like gas or I don't know the normal?
Yeah, of course. Like
Okay.
any type of electrical energy production
Yeah.
on that grid. But then also like I don't know what kind of energy, what side of the energy commodity map you land, but like when you think about natural gas production,
Hmm.
right? And where that needs to go, right?
Hmm.
Or oil production and the management and flow and like the just-in-time delivery and all of that stuff. All of these systems are going to be enhanced by this technology for sure.
Hmm. Okay. No, that's interesting. Thank you. So, for my next question, so the article I read mentioned AI agent making independent decision and processing payment without human intervention. So, this level of autonomy can be both exciting and for some a little concerning. Can you walk us through a typical decision-making scenario within this system?
Yeah, so I mean this system is really sort of predicated on obviously so for your viewers that are interested in AI, I'm sure they know
Hmm.
about large language models and et cetera. Now, from a data point of view, those are those are pretty static, right?
Hmm.
There's this high degree of latency, right? They're not real time, right? And so they can um, they can do what's called retrieval augmented generation, which is providing new data within a context window
Hmm.
and exposing that to a model so that it can reanalyze that new context
Hmm.
data, um, but use the power of that's baked into like the model's latent space to do that analysis, right? So
Hmm.
that's called RAG or retrieval augmented generation. And
Hmm.
so what this agent needs to do from time to time is
Hmm.
get a more accurate picture of
Hmm.
what's actually going on. It needs closer to real-time data, right? It
Hmm.
needs to understand the weather. It needs to understand the production that's going on around it, right? So it needs access to newer data sets, and that requires it to basically say, like, okay, historically, I should probably be asking for new data at this point. Or maybe it's getting like a real-time data feed from, about the weather,
Hmm.
right? And realizes, oh, it's sunny. I should check and see how much energy is being produced by my neighbor or my local area network, right?
Yeah.
And so it can proactively make that decision.
Hmm.
And then it's also empowered financially to some degree to go out and along with that decision, perform some kind of economic function. In this case, with this particular use case,
Hmm.
buy more data. through the API, right? So the agent's empowered both logically
Mm-hmm.
as well as from a tool selection point of view to perform that activity. And then it can do so economically because it's been like seeded with funds that enables it to go out and buy
Mm-hmm.
access to these data sets.
Mm.
Yeah.
So, in terms of security, like, trying, like, everything here is digital, digitalized, right? So, I know you've been in AI and Web3 space for a long time, so, witnessing its evolution. So, what are some of the unique advantage that combining AI with blockchain and decentralized payment system brings specifically to the energy sector compared to more traditional approach?
Yeah. I mean, so, I mean, just at the most sort of naive, rudimentary level, if you think about one agent, one air conditioning unit, or even a household and all of the devices in
Mm-hmm.
that system
Mm-hmm.
wanting to consume a data feed,
Mm-hmm.
about a local production area network,
Mm-hmm.
the reality is that data is not really worth that much, discreetly. So,
Mm-hmm.
like from one day to the next, how much is that information packet actually worth? We're probably talking fractions of a fraction of a cent, right?
Mm-hmm.
And so then it becomes a question of like, how frequently are you actually settling that bill? If you
Mm-hmm.
use traditional rails,
Mm-hmm.
you have to aggregate those transactions just to get to the lowest, denomination of that currency, like 1 cent.
Mm-hmm.
If the data itself, on a daily basis is worth a fraction of a cent, right? And so that's just one application where blockchain kind of shines through because you can you can perform microtransactions, right? You can buy this information or sell it at a fraction of a cent to any discrete actor within the network. Now, for Combiner, if it's selling access to its data, um, even at a fraction of a cent, if there's massive distribution of that, they're
Mm-hmm.
actually, they're reaping the benefits of that for each transaction, right? As opposed to them having to kind of bake into the system the aggregate, the sum that needs to happen if they were only going to take like €1, if they were only going to denominate the transaction in euros, for example, which is what
Mm-hmm.
they would have to do locally in the DACH region. Well, I
Mm-hmm.
guess, and then you've got the combination of like in the DACH region, you got Swiss francs and
Mm-hmm.
you know, you've got euros. So, there's application where through stable coins and stuff like that, it's just much easier a transactional component using blockchain
Mm-hmm.
than it is using fiat. Yeah.
Mm-hmm. Okay, so something that also track my interest. So it looks like you combine. There are multiple players in this. Like you're talking about Combiner, talking about Peak, Olas, and never mind it. So
Yeah.
like how do you collaborate? Like, is it gonna be like I know collaboration is crucial in complex tech project, but are you gonna end up merging all that, or like could you share some insight into this
Well,
scenario?
this is also where the power of blockchain shines through, right?
Yeah.
Because it's much
Mm-hmm.
easier to compartmentalize each of the contributing counterparties, right?
Mm-hmm.
Um, Attribution is you get much finer granularity on attribution with a
Mm-hmm.
blockchain than you do with conventional, networking and payment systems.
Yeah.
And so you can really discreetly measure what each counterparty is contributing, if you need to. In this use case specifically, so OLAS provided the framework for the
Mm-hmm.
agent.
Mm-hmm.
Um, Peak provided the network that
Mm-hmm.
these transactions took place on,
Mm-hmm.
right? And
Yeah.
and and in actual fact, the payment was made in Peak,
Mm-hmm.
that network's currency. It wasn't made in like a stable coin or, another major network denominated currency. It was actually made in this it's called a DPIN, a decentralized physical infrastructure network.
Mm-hmm.
That's what peak is, and it was the transactions made in its native token peak.
Mm-hmm.
Combinder is building on top of that decentralized physical infrastructure network, and so they actually want to accumulate peak. So they're willing to accept that network's token
Mm-hmm.
in exchange for the data that it's providing to this OLAS created
Mm-hmm.
um, agent. There's another counterparty called Kiko that actually built the
Mm-hmm.
agent that interfaces with the air conditioning unit.
Mm-hmm.
And then us, we're this intermediary that our technology plugs in to enable that agent
Mm-hmm.
to make the transaction using Peak with the Combinder API.
Mm-hmm.
Um, yeah. So those are the counterparties and kind of architecturally how it's structured and the different areas of expertise that were contributed to all of this.
Mm-hmm. So, are there some lesson learned from this collaboration that could be valuable for other AI projects in traditional industries?
Well, I think the biggest take home is like that this can now be done, right?
Mm-hmm.
And it's, from start to finish, it took us like 3 weeks to
Oh.
figure out what's the
Mm-hmm.
actual use case
Mm-hmm.
and then build it out and launch it.
Mm-hmm.
Um, this type of proposition 5 years ago may have taken 5 years. So it's the time to market is now, um, you know, massively compressed
Mm-hmm.
um, in comparison to sort of historic application of the similar type. Largely, that's because the interfacing for these agents has been drastically reduced, right? And you don't have to create
Mm-hmm.
the complexity in what's called effectively transfer learning with these models is like drastically easier because they have such a broad application set to start
Mm-hmm.
with. So it's just easier to kind of tune them for a particular use case. And then, we've built our technology over the course of the last, you know, call it 5 years.
Mm-hmm.
And combining it with these different providers, it just makes putting these different Lego blocks together way easier.
Mm-hmm.
So
So,
that would be one of the big takeaways is like building this type of solution against this type of use case
mm-hmm.
has been drastically the time to market has been drastically reduced. So therefore the cost is also like
Yeah.
just significantly cheaper.
Yeah. So like I was
Yeah.
reading the other day that, OpenAI is planning to, give the possibility of, creating AI agent, couple of thousand per month, that kind of subscription. So can someone with a subscription like that use it to build something like this? Like you, or do you need like a.
Yeah, I don't know if like what we're talking about realistically at scale, right? So
Mhm.
yeah, what with OpenAI, they're talking about a price range of between 2,000 and twenty
Mhm.
thousand bucks
Yeah.
per agent,
Yeah.
right? 20,000 being like the PhD level
Hmm.
agent.
Yeah.
Um, so uh, in fairness, what you would probably have is like you would pay 20,000 bucks for a month and get this PhD agent to design this system
Hmm.
that it can be rolled out in production with a bunch of agents that don't cost 20,000 bucks a month to run and operate, right?
Hmm.
Um, and so like are you going to pay 2,000 bucks a month for this type of agent? No. Um, it's arguably going to come baked into your air conditioner in the future.
Yeah.
Um, whether or not the kind of propensity shifting towards single purchase to subscription for everything from, your entertainment consumption to your automobile, we might shift to that, which is a bit crappy. But anyway,
Yeah.
yeah, I mean, the cost of these things is not very high,
Yeah.
right?
Okay.
And so, you know, and arguably these are going to be probably open source
Hmm.
agents um, that get you know embedded into your home devices.
Hmm.
Um, some type of tuning done by the manufacturer of the HVAC system, the air conditioning unit, or your refrigerator, or your stove, or whatever it is, right?
Hmm.
And then these things will
Yeah.
communicate more broadly with a much wider area network.
So if they're embedded into our HVAC system, how are you going to upgrade it? Like, is
Well,
it
it's
like,
software. You just do it over the wire,
oh,
right?
okay, you just,
So there will be a question of like what kind of hardware do you need to operate the model, right?
Mhm.
And so, there will be limitations on, you know, the 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 size and possibly the type of model that can run on that GPU
Yeah,
architecture.
yeah,
Um, but that's the same kind of constraint we have now.
yeah.
So,
And they're
you'll
getting
have
smarter
update
and
over the
smarter, right?
air and
Yeah,
yeah, like firmware updates over the air and
yeah,
that's how you'll upgrade them to a certain point, right? And then
yeah,
you'll hit the physical limitation of the hardware.
yeah, yeah. Okay. No, that's cool. So, looking ahead, Don, so where do you see this AI-driven payment in autonomous system heading into the energy sector and potentially beyond? Like, what, what's coming up?
Yeah, I mean, I think the big thing that's coming up are agents, right?
Mhm.
Agentic AI
Mhm.
agents. So you alluded to what OpenAI is alluding to coming
Mhm.
down the pipe. And then next up, sort of what we're demonstrating in our use cases, one agent, but these are going to work with other agents,
Mhm.
right? With other air conditioning units and other devices. So really what we're seeing
Mhm.
is the initial growth of multi-agent systems, or AKA they're also called swarms.
Mhm.
Um, and I think by and large, you know, that's what's going to take hold from a software point of view.
Mhm.
We will be largely ambivalent to it. These will be decision-making agents that, sit below the proverbial surface
Mhm.
and perform activities, you know, that we're largely ambivalent to. Um, but there will be entire economics that
Mhm.
are derived and driven by this.
Mhm. So, do you see any hurdle to like you know, for adoption for this kind of system? Like, what have you seen on the field?
Um, I mean, uh, obviously, it's still nascent from a technology
Mhm.
point of view, and more so, I think, from an application point of view.
Mhm.
Um, so it'll take a few years for it, especially in. I'm not. I mean, this is like I'm not going to call it hypercritical
Mhm.
application, but it's pretty critical application, right? When you start talking about infrastructure and energy in particular,
Yeah.
like there should be some risk aversion
Mhm.
in the application. So initially, like the application will be kind of, I don't know, in some sort of redundancy, right?
Mhm.
That's not going to necessarily impact the overall operation
Yeah.
of the energy distribution system.
Mhm.
And then gradually over time, this sort of passive, from a human point of view, engagement in these systems will just become more and more prevalent, right? Like
Mhm.
we will be less and less part of the operational side of these systems.
Yeah. So
The software will take over.
what about people will say, okay, what about if someone hacks it and just, shut down?
Yeah, I mean, well, what about if somebody hacks the grids now? Like, um,
Yeah.
you
It-
know,
yeah. There's always a risk, right?
adding if that's the pushback, well, somebody's gonna hack the agents on these grids. Well, yeah, people are already trying to hack the grids right now,
Yeah, that's right.
These are problems that I believe need, should be addressed, obviously, but addressed as they arise, as opposed to trying to, predict the impact of something that isn't actually there already.
Yeah. No,
Yeah.
no, that's cool. Yeah, thank you so much, Dan. I think I have all the question I wanted to you to answer, and you did it very well. And yeah, thank you so much. And
Cool. Thanks for
yeah,
having me.
yeah, I hope to have you. You work on a lot of AI projects, so I hope to have you back. To talk more about
Sure.
this stuff. Thank you.
Yeah, let me know. Thanks. Have
Yeah.
a great Friday.
Yeah, I'll talk to Victoria, and then she'll let you know when it's ready, when it's gonna be online.
Okay.
Perfect.
Sounds
Thank
good.
you.
Thanks,
Yeah.
sir.
Yeah.
Ciao. Bye.